Yeah, so today we will talk about chain rule, and as we know, we have six base cases uh, for the math method syllabus. So what we will do, firstly, we will um, talk about the base cases. So the first base case number one, that would be ddx of xn is equal to x nx n minus 1. So this is base case number 1. So what we have observed when we are learning base case number 1, that if you have x here, you should have x in the denominator. Then only you get this output. This output is valid if you have this the structure in the left hand side, where you have x to the power n and it is differentiated respect to x. Now suppose you have dx here, so the operator would be ddx, but your function is x plus 1 raised to the power n. So according to the base case number 1, to have an output, you should have x here, and that should be differentiated respect to x. So now what you have to essentially look is the compatibility between the numerator and the denominator. Now here the numerator denominator compatibility is not there, right? So now if you don't have that compatibility, what you have to do is you have to construct it. How do you construct it? Now you have x plus 1 to the power n. Now you have to differentiate. Now to differentiate x plus 1 to the power n, you have to have x plus 1 in the denominator, like this. So then the compatibility is satisfying. Then you constructed this um, uh, you know from outside from the question. So you are going to cancel that. Whatever you construct outside, you have to cancel it. And originally we had dx, so I'm going to put dx there. Now you can see the compatibility is there. Now that is x plus 1 in the denominator is the construction that is cancelled by multiplying by dx plus 1. Yeah, so if you have that construction, what we can do is we can now easily simplify. So if you get this block, now that block can be simplified very easily. So that would be n x plus 1, the whole thing raised to the power n minus 1. Why? Because if you have x, look at the base case here, if you have x in the numerator, denominator also you should have x. So then you have the output as x. So in reality, if you have dmj, mj can be anything, mj to the power n, so the answer would be n mj n minus 1, n minus 1 here, right? Any question? No. Now this is called chain rule. Okay, this is called chain. Why we call chain rule? Can you explain that? Why that name chain came? Yep. So this is called chain rule. So why we call chain rule is because you can see this connection here. See, that is why we call it a chain rule, because it's a chain. You construct it and you cancel the construction. So chain rule means, what is chain? Chain means, like, if you have a loop, the second loop is sort of connecting with this, right? So similarly, this rectangle is the first loop, the other one would be the second loop. So they are connected through dx plus 1, through this term. That's why it is called chain rule. So other than that, there is no any other reason to say. Okay, so in the first question, what we have to do is, if you check the numerator value is not equal to the denominator value. This is a very simple check actually. If the numerator is not equal to the denominator, you have to see this is related to which base case. This is related to the first base case. Why? Because of this power. You can see this is x to the power n type of a question. So if that happens, what we do is we construct your denominator. So that would be 2x plus 1, and your numerator would be 2x plus 1 to the power 5, and this is the extra term you sort of constructed, so you are going to cancel it, and that cancellation and the construction is called the chain rule. Okay, so that is the most the easiest way that you can understand this. So now when you take this block, right, so as I told you, mj, right, in the numerator and the denominator. So what you can do is you can take 5 out, and 2x plus 1 comes here. You can see the compatibility. See, mj. So this is going to be 4. And when you look at this one, so you can split this. That would be ddx of 2x plus ddx of 1. So ddx of 1 goes to 0. So this one is 2. Right. So the answer would be 10 2x plus 1 raised to the power 4. So that's the answer to that. Okay, sorry. Okay, so in the second question, you have to do the same construction. So dx squared plus 1, then you have x squared plus 1 square. So you are going to do the construction and the cancellation. Dx squared plus 1, and then divide by dx. Then you can see from this block, your answer would be 2x squared plus 1. This is going to be very easy once you know the logic. Then you see this plus sign, so you can split this. So ddx x squared plus ddx of 1. So now you can see this is going to be 0. Now here this is 2x. So then the answer would be 4x x squared plus 1, and that's the answer to that question. Okay, so now in this question we can see we have to use the product rule. Why? Because we have two functions, ex and 2x squared plus 1 raised to the power 3. There are two functions. So what I will do, I will use the product rule. This is the product rule. Plus, then I will keep 2x squared plus 1 raised to the power 3, actually not 2. And then I'm going to differentiate e to the power x. So now this is the differentiation we have here. ddx of ex, base case number 2, very easy, answer is ex. Now this is no problem, this is just a multiplication. This is not a problem, it's just a multiplication. The problem here is this. Here what we do, now we have to differentiate, but what is the base case related with? The base case is base case number 1. The related base case would be base case number 1. Why? Because of this power 3. Okay, so now knowing that, we will do the construction. So I will extract that from there to here, so that I can easily show it to you. So raised to the power 3. Now I need to do the chain rule now. Why chain rule? Because there is an incompatibility here, right? So chain rule would be, I need to construct this. So whatever here, mj, you construct here in the denominator, and then not 3, without 3, okay, without this one. Yeah, so that's why I told you we have to remember base case number 1, n is not going to be counted. So numerator would be 2x squared plus 1 raised to the power 3, and the construction is going to be cancelled with this. That is called chain rule. Why chain rule? See, look at the connection. That's why we call it chain rule. So dx. So now here we will see the first term can be simplified using the knowledge of base case number 1. That would be 3, so 2x squared plus 1, the whole thing to the power 2, multiplied with Now you have these two terms, and how you can do that: ddx of 2x squared plus ddx of 1. So this is what we have. Now what we will do, 3 2x squared plus 1 squared. Now here this 2 is a constant, so you can take it out, so this would be that, and here this one is 0. Why? Differentiation of a constant, derivative of a constant is 0, so this is what we have left. Now what we can do, so you can simplify this, and that is going to be 2 times 2x, so it's going to be 4x. So the final simplification is going to be 4 times 3 is going to be 12x. So I bring this one up here, and then 2x squared plus 1, the whole thing to the power 2, and that's the answer to that. Now once you obtain that answer to that, so I have to sub that in here, right? So the answer to the original question would be ex times 12x 2x squared plus 1 whole thing to the power 2, and then here you have ex again plus ex, and then it is going to be multiplied with here 2x squared plus 1 2x squared plus 1 raised to the power 3. So that's the answer. So you can take common factors out, but I'm not going to do that simplification here. I just wanted to show you how to do the chain rule. So now we will learn how to use the chain rule in base case number 2. So we know base case number 2 would be ddx of ex is going to be ex. So what is the significant here is, if you have x here, you should have x here, and you should have x there in the output. So in general, if you have ddmj, okay, so this is going to be emj, and then this is going to be emj. So mj can be anything, right? So mj can be anything. So for example, if you have dd e of x squared, and if you are differentiating respect to x squared, so the answer would be ex squared. So x squared becomes mj, right? So that's how you have to understand this. Now the problem is not that. The problem is when the incompatibility comes into play. So here you have the compatibility, so you can easily get the answer. So when the incompatibility comes into play, for example ddx, but here you have ex squared. Now how to do this? So now in this question you can see the incompatibility, right? So you have x squared here, see, you have x here, incompatible. Now if you have a question like this, first thing is you have to relate the question with the base case. So first of all, you have to understand this question comes from which base case. So now in this question came from base case number 2. So once you determine that, then you have to see whether you need to use the chain rule or not by looking at the values, right? So here you have to use the chain rule. Chain rule means the construction. So how do you do the construction? Here you have dex squared. So now here you construct dx squared, see, mj, right? So you're going to cancel the construction like that. So this part would be ex squared. You can see mj, right? So like I showed you in general. Now this one, what is this one? This one would be base case number 1, right? ddx of n. So the answer would be 2x1, direct base case number 1. So the answer would be 2x ex squared. So that's going to be the answer. Okay, now in this question, first of all we have to check which base case is used here. So the base case would be base case number 2, exponential, and you will see the incompatibility here. So you will do the construction. That construction is called chain rule. So that would be this. and then what you do, you're going to multiply this with, you know, the same value you constructed. So this is the chain rule, so you can see the connection between the looping, first loop and the second loop. So now the first loop, the answer would be e x squared plus x, that is not a problem. The second one, multiplication here, second one you will split it and you consider individually, so you will get ddx of x here. Now the answer to this question would be 2x, and here it would be 1. So now the answer would be 2x plus 1 exponential x squared plus x. That would be the answer to this question. Okay, so now the base case number 3. So base case number 3. So base case number 3 would be ddx of ln x. Ln, you know, natural log e base. That would be 1 divided by x. So if you have x inside here, and x should be in the denominator, and output you will have x. So here dd of mj in general, so ln mj, so is equal to 1 divided by mj. So that's how it works. For example, if you have ln x squared, and in the denominator if you have x squared, so the answer would be 1 divided by x squared. So that's easy. See, you can see the compatibility. Now the question is when you don't have the compatibility. So for example, if you have ddx of ln x squared, now here you don't have the compatibility, right? So what you will do, you will construct the denominator so that you will have the compatibility. So like this, see, now you have the compatibility, and the construction you made, you're going to cancel here. You know that is called the chain rule. Now this block, the first block would be 1 divided by x squared times second block, right? So the second block would be 2x. So it's going to be 2x now. Okay. So the answer would be 2 divided by x. So now we will discuss base case number 4, 5, 6 together, because they are about the secular functions. So the base case number 4 is about ddx of sine x, and that would be cosine x, right? And base case number 4, 5, that would be ddx of cosine x, and that's going to be minus sine x. Okay, so and now base case number 6, that will be ddx of tan x, and that is going to be sec squared x. Now we know that, you know, if you have x here, you should have x in the denominator. That is called the compatibility. If you have the compatibility, output has the same thing. See, you have the compatibility here. Now what we will do, we will discuss a few examples here so that we can learn how to use the chain rule for base case 4, 5, 6, all three, because they are circular functions. It's easy. The only change is the function, the rest is going to be the same. Okay, so the first question, if you have ddx of sine x squared, right? So here you can see the incompatibility, and you know this is under base case number 4 because it's sine. So what you do, you construct it. So it's going to be sine x squared multiplied with dx squared divided by dx. So once you know this, this is going to be really fast. So this is now cos x squared. You can see the compatibility here, times ddx of x squared would be 2x, base case number 1. The answer would be 2x cos x squared. Now if I use a different one for cos, that would be ddx of cosine 2x plus 1, if I use that, so this is going to be chain rule, right? Because you can see the incompatibility here. So that would be d2x plus 1, and numerator cosine 2x plus 1 multiplied with, you're going to cancel the construction, which is called the chain rule, and you divide by dx. So now for this part, what you get is minus sine 2x plus 1. You can see the compatibility, multiplied with, here it's going to be 2. It's going to be 2, right? So the answer would be minus 2 sine 2x plus 1, and that's going to be the answer. Now third example with tan. So if you have ddx of tan square root of x, then what you have to do is, see, incompatibility is there. So d square root of x, you construct it because you have this. See, now it is compatible. Then you are going to cancel whatever you construct. Then from here you can easily get sec squared square root of x. You can see the compatibility, square root of x, square root of x, square root of x. Then multiplication, then you have ddx of x half. So you know ddx of x half would be 1 divided by 2 square root of x. So it's easy, base case number 1, right? Base case number 1, if you do that, you get that. So the answer would be sec squared square root of x divided by 2x square root of. That's the answer to that.